Hello, welcome to Chapter 7, Section 2. Today we're talking about sample proportions. So today's video is going to be real short because we kind of looked at in class with our little simulation activity what sample proportions would look like. So we already talked last video about how if we're dealing with proportions in a sampling distribution, we would use the symbol p with a hat on top, so p hat, to find that number in a problem. Sometimes they'll give it to you in a percent, sometimes they'll give it to you like this many out of this many people or items, whatever. So depending on the situation, depending on the problem, if you need to find your own fraction or your own decimal or proportion or percent, then you would take the number of the successes in your sample and divide it by the sample size. Sometimes you'll see it written as x over n. So x standing for how many successes you have in your sample. That's also how your calculator is going to use the letters, variables for it. So when we talk about the sampling distribution of sample proportions, we want to be able to describe the distribution basically. So we know the center when we're talking about the distribution. The center is just going to be whatever the population proportion is. And remember, we use lowercase p to stand for the population proportion. And then when we talk about the spread, we talk about the standard deviation. So the standard deviation of our sample proportions is going to be giant square root of the population proportion p times 1 minus p all divided by n. So the entire thing is under the square root. So when we talk about like the center and the spread, we're using these symbols here. So it's like the mean of the sample proportions, the standard deviation of the sample proportions p hat. When we talk about its shape, remember we can only do probability calculations when it's normally distributed. So we want it to be approximately normal so that we can label the mean with our center and our standard deviation of our sample proportions. But in order for our distribution to become that approximately normal shape, we found out that we have to meet that large counts condition, or the large counts rule. So remember, that was the one where n times p has to be greater than or equal to 10. N times 1 minus p also has to be greater than or equal to 10. So remember, both of these rules have to apply before we can consider it approximately normal. One other thing was we mentioned the 10% condition before. So the 10% condition applies to our standard deviation formula. If the 10% condition isn't met, we're technically not allowed to find the standard or use the standard deviation formula to find the spread. So before we do any problem where we needed to calculate probabilities, we have to check for these two things. The 10% condition, remember that's the one where your sample size, whatever your lowercase n is, it has to be less than 10% of the overall population. So you'll see the book use lowercase n to stand for a sample size and the uppercase n to stand for the population size. Then we also have to check to make sure our large counts conditions are met so that we can actually use our z-scores and stuff to calculate our probabilities. Let's do a quick example. So we've got a superintendent of a large school district, like us, wants to know what proportion of middle school students in his district are planning to attend a four-year college or university. Suppose that 80% of all middle school students in his district are planning to attend a four-year college or university. What is the probability that in a simple random sample of size 125 will give a result within 7 percentage points of the true value? So I've highlighted a couple things here. So first, it says, suppose that 80% of all middle school students. So right there, they're talking about all middle school students, which is our population. So 80% would be the proportion of that population. So basically they're telling us P, our population proportion, is 80%, or we can write it as 0.80. Okay, Then they're asking about what is the probability that an SRS of size 125 will give a result within 7 percentage points of the true value. Well, our true value is at 80%. So within 7 percentage points means we're looking for the probability that our sample proportion is going to be between 73% to 87%, because those are the numbers within 7 percentage points of the true value. Okay, so in order to calculate this probability, we want to use that normal curve. But before we can do that, we have to make sure that we actually can use a normal curve. So before we can figure out the standard deviation, we know the mean is going to be the 80%. But before we can use the standard deviation, we have to make sure that 10% condition is met. So the 10% condition says that our sample size has to be less than 10% of the population. So our sample size is 125. If we take the 125 times 10, that'll give us, 1,250, which is a much smaller number than what the total amount of middle school students would be in a large school district. So we're basically making sure that our sample size, if we multiply it by 10, is less than what the whole population of middle school students would be, so that we can check for that less than 10% of the population rule. Okay, so in words, I would say something like there are more than 1,250 middle school students in a large school district. So our 10% condition is met. Okay, so now we're allowed to find our standard deviation. So our standard deviation is p times 1 minus p divided by n. So p for us is 0.80. 1 minus p would be 0.20, and is our sample size of 125. When we do that, we get a standard deviation of 0.036. Cool. All right. And so lastly, I just need to make sure that it's actually approximately normal, because before we can do any calculations, if it's not approximately normal, this is all useless. So we're going to check that large counts condition. So the large counts condition, we are checking for n times p. That has to be greater than or equal to 10, and n times 1 minus p also has to be greater than or equal to 10. So our n, sample size, is 125. P was 0.80. When I do that, I get 100, and then I'm also going to check my 125 times 0.20. I get 25 from that. So both of these are greater than or equal to 10, so great. Our large counts condition is met, and we can proceed with our normal approximations. Okay, so if we are looking for our probability to be within 7 percentage points, we're looking at shading in between 0.73 and 0.87. So we're looking for this area right in the middle. So using our z-scores, we would have 2 to find, but really they're the same distance away from the mean. So we know one z-score is going to be the opposite version of the other. So one's going to be negative, one's going to be positive. I ended up with z-scores of negative 1.94 and positive 1.94. So at this point, now that I've shown my work for z-scores, I'm going to just use the calculator to calculate the probabilities. So remember, we're looking for normal CDF, so second vars, number 2. Normal CDF, I'm just going to use the z-scores that I found. So we're shading between a z-score of negative 1.94 to positive 1.94, and since these are z-scores, the mean and standard deviation is going to be 0 and 1. Enter. There's my probability, so 0.9476. And of course, we're also going to answer it with words. So all we're doing is just restating the question. So it says, what is the probability that blah, blah, blah. So we're just going to say the probability that an SRS of size 125 will give a result within 7% of the, and then I'm just going to replace the context in here. The true proportion of middle school students planning on attending a 4-year college or university is 94.76%. And that's it for this section. Thanks for watching. Bye.